Welcome back. As you can see, I've let my spawn volumes run for a little while and kind of creating a black hole of pickups over here. It's about to collapse at any instant. And big bunch of batteries that are doing me no good. I can't use them to power up. They're just sort of sitting there cluttering up my level. So let's work on some of the collection code. Now the collection code is going to have two parts. Some of it's going to be on the pickups and some of it's going to be on the character. The pickups will decide how they respond to being collected, and the character will actually call the collection functions. So let's pull that up. And first let's put our collected functions on our base pickup. Like every pickup will respond to being collected, therefore that's where all the base code should go. So it's going to be a public pickup function so that it can be called, like I said, by our character. It's going to be a void function. And let's call it was collected. So what happens when, well, let's go with is collected. What happens when the battery is collected? And we're going to make this a blueprint native event using that ufunction macro. And actually, I'm going to put this back on was collected. Is collected seems like it should say whether or not the battery or the pickup is currently collected. So blueprint native events have some behavior that's set up in code and some behavior that can be set up in blueprints. You don't have to set up the blueprint behavior. If you just set up code behavior, only the code behavior will be called. And you can override the behavior in blueprints and either call back to the code implementation or not. We're going to call back to the code implementation, and it is an option. And this is going to be the function to call when the pickup is collected. Okay, because this is a blueprint native event, we also need to make the implementation declaration. So that's going to be virtual, so it can be overridden by any child classes. And the naming scheme here is basically our previous function name, which apparently I've finally decided is was collected, and then underscore implementation. This function here, this was collected implementation, is the one that you will override in any child code classes. However, you'll always only call it as was collected. That way it can call both the code implementations and the blueprint implementations just with one function call. You don't have to, put them together or always remember to have one or the other. So that is set up here. And for the base pickup, we're just going to put together a debug string to say what you collected. So hey pickup, what was collected? And again, we have the implementation. And we're just going to log a debug message. Using fstring, we're going to make this pickup debug string. And we're going to use that to get the name of basically our pickup of what we're currently in. And then we're going to use uelog log class. This is just, you can set a different category, but log class works for this basic implementation. The verbosity is for log. We're going to use the text macro and say you have collected, put in the string variable, then the pickup debug string. So again, this is just going to log for all pickups of any type, the ones that are big boxes that stay in the sky, the batteries that rain down, if we do some sort of power up pickup later, they will always print to the log that you've collected them, which is awesome to help debugging. Now we will go to our battery pickup and override this was collected implementation function with a little bit of extra behavior. first we'll go to the header, and we are going to, again, it's public because we want it to be able to be called by other classes. Override the was collected function. And again, we're using implementation here because it's a Blueprint native event. So void was collected implementation. One too many M's there. Implementation. Override. So take whatever behavior was defined up here in the base pickup, and then we're going to override it. To override it, we go to the source file. We're going to write out the function definition, which again has the implementation. And you'll see these implementation keywords also sometimes for server or client macro keywords. It's basically just this is defined in code, will be called in specific cases. We do want to, there's two things we want to do when a battery is collected. First, we want to use the base pickup behavior. To do that, we call the parent function using super. Then we want to destroy the battery. We didn't put the destruction on the base pickup because there may be some pickups that only deactivate for a short time and then reactivate, like a power-up. And so destruction is not universally applicable. So we wanted to put it on just on the battery where we know we want to destroy them. I think that is everything we have to do for the battery. So let's do a quick compile and then talk about what's going to actually be on the character. So we're just going to build right here because we're not switching back to the editor yet. So we have these batteries and they have two collection functions, one on the plain pickup and one on the battery pickup. However, right now there's nothing calling them. So what we're going to do is we're going to first add a big sphere to our character so that it can overlap some number of pickups in the world. And then we are going to add a function in the next video that will call was collected on all pickups that are currently in that sphere. Let me just take a look really quick at what this error is, and when I get it sorted, I will let you know. Okay, looks like good news. It was just a little bit of a compiler hiccup. The code as written previously in the video should all work. So that's good. All right, switch to our character and create another component, which at this point should be fairly straightforward. It's the same method we've used before, and so I'm going to go through it a little more quickly than I did the other two components. So we're going to our header file for our battery collector character, and this is actually the character that was created when we made the template. So if you notice, there's actually a lot of boilerplate already in here. So we're actually going to create a little component here. Let's use this camera component as our template. It's going to be, again, this will be our collection sphere. And it will be a uSphere component. And we'll again call it collection sphere. Down here where the other force inline class or component return functions or accessor functions are, we'll make one of those. So returns collection sphere subobject. And again, just using this as a template. This is the third component we've added over the course of the series. So force inline class uSphere component. We'll call this getSphere component, obviously. And and return collection sphere. Actually, let's change this function name to get collection sphere just to keep the naming consistent. So very much like the camera boom and the follow camera that were added in the code class for the template, we're going to just make a collection sphere. Then we will go to the constructor here, which has got a bunch of properties already set up. And here at the bottom, we will create the collection sphere as well. So collection sphere, we're going to use that create default subobject, templating. For our uSphere component. If you wanted to make a box or a capsule around the character, you could certainly do that too. I just like the sphere for being able to extend kind of at a large volume around the character. And we are going to attach the collection sphere. This is actually, we're not going to make it the root component because it's already got a root component. We are going to attach it to the root instead, which is again a very simple line of code here. Finally, we will quickly set the sphere radius to using, a function that's on the sphere component to set sphere radius, and we'll set that to 200. This is, you can tweak it and go larger or smaller, but just for the sort of balanced feeling we had at the end, 200 was the radius that we went with. So for this video, we went through and added collection functions to our base pickup and our battery pickup, as well as a collection sphere that we'll use to test which pickups should be collected. And in the next video, we'll actually write the collection function. Thanks!